Today we're going to be focusing on the importance of capacity, and we'll be looking at application requirements, device requirements, and some general guidelines for gaining more capacity. It is an essential element of wireless LAN design, implementation, monitoring, and support with modern networks, because we're no longer in that era where we can simply say we'll install a few access points and people will have wireless access, because we're now running critical applications, or we're marketing that we provide wireless access at hotels and other hospitality areas, arenas, and things like this. And when you market that you're providing wireless access and then people connect to the wireless network and do not have effective wireless access to the internet, let's just say they get a little bit frustrated. So to avoid that, we have to make sure that we've designed for capacity, and that's what we'll be looking at today. In the 5 gigahertz space, we have more channels. So in most of the world, you're going to have at least the lower 8 channels, 36 through 64, and then also 149 through 165 in many. In some parts of the world, you may or may not have these middle channels that are sometimes called DFS channels. Certainly 100 through 144 may or may not be available. And in some parts of the world, they may be the primary channels you end up using. The important thing is to know that you're always going to have at least 4 channels, more likely 8, 9, or even 12 or 13 channels that are available to you. So because we have so many channels in 5 gigahertz, and I'm talking about 20 megahertz channels, of course, it's going to be a lot easier to deploy our channel reuse plan so that we're not having our APs step on each other, but even more importantly, our clients, because we can have 2 or 3 channels of separation between our different cells. Now, that is within some level of constraints, because when we're doing higher density, even in 5 gigahertz, co-channel interference is going to go up. And we have to understand that even when we turn down the output power on the APs in 5 gigahertz, because we're doing higher density deployments in a space, there's still going to be co-channel interference, because it's not just about the APs, it's also about the clients. And you can't, at least very often, turn down the output power on the clients like you can on the APs. So that becomes a big factor once you get below 20 to 25 milliwatts of output power.